A distribution of values is normal, with a mean of 98.1 and a standard deviation of 85.2. Find the probability that a randomly selected value is greater than 336.7. So the probability that a value is greater than 336.7. Well, we know that our distribution is normally distributed. So let's draw a bell curve. And the pertinent information for any bell curve is the value of the mean, which is the center point of our data, and the standard deviation. Now this standard deviation is very large in comparison to the mean, but that's perfectly okay. We're looking for 336.7, which doesn't really matter where you put that, but it's to the right of 98.1, so put it to the right. And if it's greater than that, we would shade to the right from there. Now to find the area of that shaded region, we would use the function normal CDF. Normal CDF takes up to 4 inputs. The first two are the lower bound of your shaded region and the upper bound of your shaded region. So we go to positive infinity for this, because this continues on forever. But there's no infinity key on the calculator, so we're going to use e to the 99th, which just means 1 times 10 to the 99th power. The mean is 98.1, and the standard deviation is 85.2. And those are the last two inputs that we give to the function. So let's get out our calculator to solve this. If I hit second and distribution, then down to normal CDF, it takes the 4 inputs that I've provided, so 336.7, comma, then hit second and comma to get that E, and then 99. Then the mean is 98.1, and the standard deviation is 85.2. So that gives me a probability of 0.0026. Now, if you were using the calculator and saw a menu come up when you did the normal CDF, then that just means you have one of the later model calculators, which it's taking the same 4 inputs, but it's trying to give you hints as to what those inputs are. So the lower bound, 336.7. The upper bound is already positive infinity, I'll leave that. Then 98.1 and 85.2. When you hit paste, all it does is just put that function on the home screen for you. So it doesn't matter if you have that turned on or not, you still get the same results.